Yes, welcome to today's session. So like I said, so far we have discussed the proportionality theorem, and we went further to discuss the midpoint theorem, and then we also discussed a bit of similarity there, right? So we'll do a bit of a recap on that, and then we just finish off, right? So like I said, that this is the last part of Euclidean geometry. Okay, so sorry. So all right. So if we do a bit of a recap, right? We said if so, I'm gonna draw this table here, right? You're more than welcome to also draw it, but as I will send you the what is it? As I'll send you this document, and then you'll be able to have it, right? So remember, Euclidean geometry is all about an if and then situation, right? If this is happening, then this is what you conclude. Okay, if this is what you see, then you conclude that. Okay, so for the first one, which is the proportionality theorem, what are we saying there? We're saying if you have a triangle, right? If you have your triangle like this, and then you have a line drawn inside of the triangle that is parallel to one side of the triangle, right? Let's just name our triangle A, B, C, and then D and E, right? If we have a line that is parallel to one side of the triangle, as you can see there, we then conclude to say then AD over, right? So AD over BD, right? AD over BD would be equal to AE over EC, okay? AE over EC. Now we said the reason you provide for that, you say it is because you have a line that is parallel to one side of a triangle, right? Because you have a line that is parallel to one side of a triangle. So that line cuts the other two sides, right? Line DE cuts this side and that side in the same proportion. That is why we have that. That is the first theorem, proportionality theorem. That's what you must look for. If you have any situation like this, you conclude this, okay? Now in terms of then the second one we then talked about, we said if you have a situation like this, right? So if you still do have a triangle, if you have a triangle like this, but now this time it happens that you are given the following. This is A, B, and then C, D, and E. If you are given that maybe this is let's just say 2 centimeters, right? 2 centimeters, and then maybe this part is 4 centimeters, and then you are given that this side it is 6 centimeters, and then 12 centimeters, right? If you're given something like this, right, whereby AB over BC would be equal to 2 centimeters over 4 centimeter, right? The ratio is 1 over 2. And then if it happens that you calculate AD over DE, right, then you also get that it is 6 centimeter over 12 centimeter, and get the answer as 1 over 2. Since the answer is the same, right, if that answer is the same, then you conclude to say BD will be parallel to CE, because these are in the same proportion, and that is only true if BD, this side, is parallel to the third side of a triangle. Okay, so what would be your reason? Your reason, you would say here we're saying line parallel to one side of a triangle, right? Here you would say sides in the same proportion, right? Sides in the same proportion, even if you can say prop or you write proportion, right? That is what you conclude. If you see a situation like this, you conclude to say that, and then you give a reason why you are concluding that. Because the sides are in the same proportion, it means BD should be parallel to CE. All right, so that was the second one. And then we also had another one, the third one, right, which was our midpoint theorem. Now in terms of that third one, right, we said if you do have a triangle like this, right, and then okay, you have something that smells like this, right, and then you have A, B, C, D, E. If it happens that this is a midpoint and this is also a midpoint, to say AB is equal to BC, AE is equal to ED. If you have this situation, you conclude to say BE will be parallel to CD. Why? You say you use the reason midpoint theorem, right? Midpoint theorem. So you can write it in full. Okay, that is what you conclude. And you don't just conclude this, you conclude also to say that BE, which is this line, is going to be half of CD, which is the third side. Okay, half of CD. What is your reason? Your reason would be midpoint theorem, the same thing. Okay, that is it. So if you identify any situation like this whereby you have a line joining two midpoints, here you must remember that you have a line joining two midpoints, right? A line joining two midpoints of a triangle, then you must know that that line is going to be parallel to the third side, and it's going to be half of the third side. I hope that is clear. And then now we go further, right, to then say, okay, we also have a converse of that. Okay, we have a converse of that, of which there we would have a triangle as we are having here, right? We would have our triangle here, and then we would be given the following. So if this is A, B, C, D, E, we would be given that here maybe this side, this one is equal to that, and then we're given that B is parallel to CD. Once we have a situation like this, good people, remember that we conclude to say AE then should be also equal to ED. What is your reason? You write converse, right, is the reverse of midpoint theorem. Converse of midpoint theorem there. Okay, midpoint theorem. And then you also conclude to say BE, oh sorry, I think I said, yeah, I said AE should be equal to ED if you have the following situation. Also you can conclude to say BE will be half of CD. Okay, still you say converse of midpoint theorem. Why are we saying converse, right? We are saying converse because we don't have two midpoints, right? I will write it there in just a second. We are saying converse because we don't have two midpoints, right? We are saying converse because we have one midpoint, right? We have one midpoint and parallel line, right? A pair of parallel lines. Okay, parallel lines. So if you have one midpoint and parallel lines, that is the converse. But if you have two midpoints that are joined together, you say is the midpoint theorem. Right, I hope that is clear. So that is what we were discussing in past few sessions, right? That we were discussing our Euclidean geometry, right? Our Euclidean geometry. So this is what we have there, right? So far, if you have a pair of parallel lines, you conclude to say they're in the same proportion. AD over DB will be equal to A over EC. If the sides are in proportion, meaning the sides have the same ratio, then it means that that line joining the sides should be parallel to the third side of the triangle. Your reason will be sides in same proportion, or you can call it a converse, meaning it's like a reverse. Okay, because this is only true when you have parallel lines. If you are given this statement, then you are going to say that line should be parallel. And then if you have two midpoints joined together, that is our midpoint theorem. If you have one midpoint and parallel lines, that is the converse, right? You identify that as the converse. Okay, and then now I think from this one, that is where we kind of like ended, right? That is where we kind of like ended. Today we're gonna like discuss our similarity theorem. So make sure that you just have this handy with you, because the riders that we're going to solve, they're gonna involve these questions, right? In fact, just before we do this, we do similarity, I do have a question here that I was compiling a document for my grade 11s today, and then I stumbled upon very, very interesting questions, especially for grade 12. So I'm just gonna share that with you right now, and then we're going to look at it. I think it was from November 2023. Yeah, this is the one. So we're just gonna look at some few questions on that. So hoping it is the one. Okay, it's fine. I think this should do. So let me just share the screen. As always, try to confirm with me if you can see the screen, right? And then we take a look at that. Okay, anyone, can you confirm with me if you can see that? This is the question paper here, right? It was an interesting question for those who are rewriting, right? It was for last year. Those people were rewriting in June. Perfect. Right. So yeah, they were asked quite interesting questions. You know, when you are rewriting, they make sure that they go all out. Yeah. So let's look at this question here, right? This one here. I'm going to try my best to make sure that I at least try to give you a revision on grade 11 Euclidean geometry, because you can see it's asked. Even though you're in grade 12, they ask it, right? So let's look at this one, and then we'll look at how we are supposed to do it there. Let me see if it's visible. Right. So I'll also send it in the group so that we can just check it out, right? And then we'll discuss it. Let me just give you 5 minutes for that, so we can say 7:30 there. We discuss the solutions. Let me try to send it in the group. Sorry. Okay, it is here. Yes, Lebu, you are raising your hand. Okay, alright, no problem. just a second so that I can send it. Let me